All right, so yesterday we went over the histograms and a couple different ways to display a histogram. And then we have a few other graphs that we can use, and they're all very similar to the histogram in construction. If we already have a histogram, getting to the next one is a very, very simple process. Doesn't take very long, okay? The first one being a frequency polygon. The difference between a histogram and the frequency polygon is that it highlights the continuous change in the frequencies. And so when you look at the slope of the line, the steeper the slope, the sharper the change, okay? Some of the things to note in the similarities between the frequency distribution and the frequency polygon, as well as some differences. Frequency polygons always start and end on the x-axis. In order to achieve that, you have to extend the horizontal scale by one more class in each direction based on the midpoint. Okay, so if we take our class width for our histogram from yesterday, and remember our class width was 36, so we want to extend one more class lower and one more class higher by 36, and that's how we get the 136.5 and the 424.5. So that way those are empty classes that have zero frequency. So our frequency polygon starts and ends on the x-axis, on the horizontal axis. So we want it to end there. Other than that, the points represent the height or the frequency of each class. And so when we have our first class, which is now the second one, with the same midpoint of 172.5, midpoint of 172.5, we have a frequency of 3, so our dot goes all the way up to 3 on the vertical axis, down to 2 for the next, up to 5 for the next. So imagine we take this same graph, we put a dot here, 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 and then down on the x-axis on each side, and that is our frequency polygon. Okay? So a couple slight adjustments makes it very quick to go from a histogram to a frequency polygon. Okay? Again, the point is to just highlight the data in a different way, looking at the change in frequencies from class to class. We also have relative frequency histograms. So part of our big frequency distribution included those relative frequencies. So the patterns are going to be very similar, but the bars will be slightly different. But what we're looking at now is percentages instead of the frequencies. So just the same way that we construct a frequency histogram, but instead of using the frequency, we use the relative frequency. Okay? So yesterday we found that the first class had a relative frequency of 10%, and so that bar goes up to 10%. And the second class had a relative frequency of 7%, so the bar goes up to 7, and so on and so forth for 17 and 20 and 23 and 13, and so on. So for all relative frequencies that we found, we use those as the height of the bar instead of the numerical frequency for that. Okay, and again, those totals should add up to 100%, but instead of giving us raw numbers, it gives us percentages. Then we also have I think it's called an Ogive, if I remember correctly, a cumulative frequency graph. And it displays the cumulative frequency of each class at the upper boundary. So that was that last column in our frequency distribution from yesterday. We found the cumulative frequency, where we added each frequency to the previous total so far. Okay? And so here's kind of it relisted from yesterday. We had our class boundaries. Okay? But this time we're just focusing on the upper class boundary at the end, up to 190.5. That's the upper class boundary of the first class. the first class had a frequency of 3, so the cumulative is 3. When we get to the next upper class boundary, we had a frequency of 2. We want to add it to the previous cumulative frequency to get 5. Then we take 5 and add it to the previous cumulative frequency to get 10. So we get all of that growing total, and the cumulative frequency graph just plots that change over time. So a cumulative frequency graph always goes up and to the right. It always has an increasing slope. It can never go down. Now again, the sharper the slope, the faster it's increasing in its cumulative frequency. And so we can look and notice trends for where our biggest increases were. Okay, some time periods where we have really big increase, some time periods where we have lower increases. Okay, several different ways to kind of analyze that information, and it shows trends over that period. All right. Other than that, it's a lot of, once we have the frequency table, these graphs are really easy to construct. Just making sure that you label your axes, and it just kind of depends on what we want to do. Will depend on which graph is more useful for us. Sometimes looking at a combination of them can also be useful. Okay? But all of these are based off of the frequency distribution. And once we have the frequency distribution, getting these graphs is a relatively quick and straightforward process. Okay? See, that was relatively painless, right? 6 minutes and 45